Mole, also spelled mole, in chemistry, a standard scientific unit for measuring large quantities of very small entities such as atoms, molecules, or other specified particles. The mole designates an extremely large number of units, 6.0221407 times 1023. The General Conference on Weights and Measures defined the mole as this number for the International System of Units, SI, effective from May 20, 2019. The mole was previously defined as the number of atoms determined experimentally to be found in 12 grams of carbon-12. The number of units in a mole also bears the name Avogadro's number, or Avogadro's constant, in honor of the Italian physicist Amedeo Avogadro, 1776 to 1856. Avogadro proposed that equal volumes of gases under the same conditions contain the same number of molecules, a hypothesis that proved useful in determining atomic and molecular weights and which led to the concept of the mole. See Avogadro's law. The number of atoms or other particles in a mole is the same for all substances. The mole is related to the mass of an element in the following way: 1 mole of carbon-12 atoms has 6.0221407 times 1023 atoms and a mass of 12 grams. In comparison, 1 mole of oxygen consists, by definition, of the same number of atoms as carbon-12, but it has a mass of 15.999 grams. Oxygen, therefore, has a greater mass than carbon. This reasoning also can be applied to molecular or formula weights. The concept of the mole helps to put quantitative information about what happens in a chemical equation on a macroscopic level. For example, in the chemical reaction 2H2OO2 plus 2H2, 2 moles of water are decomposed into 2 moles of molecular hydrogen and 1 mole of molecular oxygen. The mole can be used to determine the simplest formula of a compound and to calculate the quantities involved in chemical reactions. When dealing with reactions that take place in solutions, the related concept of molarity is useful. Molarity, M, is defined as the number of moles of a solute in a liter of solution.